Hello, everybody. Thank you, Thibaut, for initiating the Spartacus platform for the archaeology of the Black Sea, and of course, for the opportunity to present and discuss some results of my archaeometric studies on the marble used for art and architecture in Histria during the Greek period. Before proceeding, I would like to ask you if you can hear me properly. Thank you. My talk, Tracing Marble Path, Provenance and Use at Histria from the Archaic to the Hellenistic Period, a slightly revised title than the advertised one, seeks to present preliminary results of an archaeometric study of the marble used for sacral architecture, votives, and statue bases during the Greek phases of the Black Sea settlement. Beyond the provenance matter, my aim is to identify patterns of marble distribution and use in the pre-Roman period, particularly in this peripheral region of the Greek world. After a brief introduction to the site of Histria, outlining the current state of research on the origin and use of lithic material, and situating my own investigation within the scholarly context, I will present the methodology adopted for the archaeometric study and also maybe give you a hint of a new digital tool for marble provenance. The main part of the talk will focus on the source of marble use at Histria and discuss the historical implications of these results. Istros, or Histria, as it has been established by the Romanian archaeological research, has been a recurring focus of this platform in recent years and is, for most participants, a well-known Greek settlement on the western Black Sea coast. I think most of you know it better than me. Founded in the late 7th century BC, the Milesian colony south of the Danube River, Histria, developed into one of the earliest Greek urbans of this region. On the left, you can see the eastern part of the Roman province Moesia Inferior, including the Black Sea coast, and showing the position of Histria, while on the right, an aerial photograph showing the main archaeological site, today delimited by the late antique city wall. During the Greek period, the urban area extended further to the west to include the so-called plateau. Over the time, however, the settlement was progressively reduced to the area visible today. The greatest concentration of Greek period architectural remains is found in the so-called sacred area, located in the northeastern part of the late antique enclosure. You can see it on the left. This area, which functioned as a sanctuary from the 7th to the mid-1st century BC, functioned as sanctuary before being abandoned and later overbuilt by a residential sector, contains high density of sacred stone structures as well as numerous marble votive finds. Given the long tradition of archaeological research at Histria and the importance of the Greek architectural remains for the reconstruction of the earlier settlement phases, interest in the origin of the lithological material used in sacred architecture has remained constant over the past decades. As early as 1983, Alexandru Avram and the geologist Adrian Muraru published an article identifying most of the lithic material used at Histria as being of regional origin, with the Turonian limestone sourced from the Babadag area just north of the Greek settlement as the most commonly employed one. Although Histria was founded directly on a green schist plateau, this friable material, which splits into layers, was not considered suitable for construction. Consequently, the Milesian settlers turned to the surrounding landscape in search of lithic resources, identifying quarries able to provide blocks of appropriate dimension. The widespread use of Turonian limestone for the archaic monuments in the sacred area was confirmed in 2013 by a study published by Iulian Bârzescu and the geologist Albert Baltres, which advanced the hypothesis that most of the Turonian limestone used for archaic architecture and votives was probably brought to Histria from Orgame, the only location close to the shoreline where quarries have been identified. Although the origin of the marble was not of concern of the two authors, the subject itself was examined at the beginning of the 2000 years in the context of Maria Alexandrescu Vianu's analysis of the Histrian sculptural material. Her collaboration with Mircea Penția, a Romanian physicist, led to initial conclusions about the origin of the marble material used in Histria that were published in 2010 in the proceedings volume Parialitos. You can see it on the left. Their study was based on isotopic signatures of marble objects from Histria, from both the local museum but also from the collection in the National Museum in Bucharest, and combined a statistic analysis of the isotopic signatures with a mineralogical petrographic analysis undertaken by Zachary Sharp. The most surprising result of this investigation concerned the origin of the marble facade of the Hellenistic temple of Theos Megas. Although the dedication is attributed to a Thasian citizen, the building was apparently not constructed with marble from the homonymous island of Tassos, as epigraphic evidence would suggest, but rather with marble from the island of Proconnesos in the Propontis. As part of my PhD project that you can see on the right, I also conducted a limited archaeometric investigation of Histrian marble. This study focused on the Roman imperial marble trade and included only a small number of samples from marble architectural elements used for veneering in the Roman imperial bath at Histria. My current interest in Histrian material arises from an interdisciplinary research project on the marble resources of the Meander Valley, with a particular focus on the marble architecture of Roman imperial Miletus, the city that founded Histria. Within the framework of DFG, or the German Research Foundation founded project, Construction Processes and Economic Dynamics in Imperial Miletus, Economic History and Archaeometric Study of Building Materials in the Meander Valley, I investigated the local Milesian marble sources located along the shores of the Latvian Gulf. You can see them here on the map. The Latvian Gulf, and thought to establish a chronology for the exploitation of these quarries. Because certain districts of the ancient marble quarries and archaic material from Miletus displayed similar distinctive isotopic and characteristics, yet the available data remained insufficient and inconclusive, I decided to extend my research to the Milesian colony of Histria. The aim was to determine whether archaic Histrian material might contain Milesian marble imports and thereby contribute to a better understanding of the early exploitation and use of marble in Miletus. Needless to say, these expectations were ultimately disappointed. No evidence of marble of Milesian origin could be identified at Histria, either in the archaic or in the late phases. Nevertheless, the sampling campaign carried out in 2021, undertaking with local support from Iulian Bârzescu, whom I would like to thank, yielded highly valuable insights into the distribution patterns of marble on the Black Sea coast during the Greek period, which I would be pleased to discuss with you. Before presenting these results, I briefly introduce the methodological approach. At first sight, it may appear abstract, particularly to archaeologists accustomed to traditional argumentative methods and less familiar with natural scientific and statistical analysis. Nevertheless, I want to encourage my colleagues, archaeologists, who rely on such results to engage with this method and to critically assess them. Let me bring. As shown on the slide, this is one of the most common graphical representations used to present the results of an archaeometric analysis aimed at determining the geographic origin of marble used in antiquity. Yeah? The method is based on the isotopic signature of the marble, which geologically speaking, is a calcium carbonate. Could be also a magnesium carbonate. But most of them are calcium carbonate. The isotopic signature refers to the ratios of stable carbon and oxygen isotope within the rock, as indicated by the annotations on the graph axis. Yeah? Be aware if all the graphs you use have this kind of annotations. Yeah? Provenance is assessed by plotting the isotopic value of an artifact as a data point. Yeah, it could be a symbol. You see there are, I don't know, triangles, rectangles, whatsoever, crosses, whatsoever, and comparing them with a reference database of quarry sample, which are represented as so-called probability ellipses. And that's what you can see here on the left. I don't know if you can see my mouse, probably, I hope so. So you see it on this sample on the left, yeah, where I think I also have the distance between the artifact, between an artifact's isotopic point and the center of the given ellipse indicates the probability that the marble artifact originated from the corresponding quarry field. Yeah, this is a diagram on the left, shows the position of the archaic samples from Histria in relation to the isotopic fields of Miletus quarries as I defined them in one preliminary publication in 2020. You can see, it's the Histrian material, it's just outside the ellipses with these two samples, somehow, but very far away from the center of Miletus too. So this is a clear, not only that, also the mineralogical petrographical analysis do not support any kind of assignment to Miletus. But, once you have your data and you start doing the statistic, and I had so high hopes with this material, yeah, when you get this result and everything is just outside the ellipse, you can imagine how disappointed one can be. The diagram on the right, I hope you can see it, present the results obtained by the team analyzing the sculptural finds from Histria, which included Mircea Penția, Norman Hertz, which is the founding father of the Asmosia, and Zachary Sharp. Although both diagrams are based on the same methodological principles, the latter, so the right diagram, incorporates a significantly larger number of reference quarries, which explains the pronounced overlap between the probability ellipses. So you see here, it's everything so clear. Here it's all overlapping. Yeah, this is a very common case. Yeah, this is something that archaeologists are not aware. So I could also, in this graph of Miletus, I could include further quarries and it would look exactly the same. Yeah, so it's always a matter of choosing which quarries or which database quarry you want to compare your data to. Yeah. While isotopic signature remain a powerful tool for marble provenancing, the growing body of data on ancient quarry districts and the recognition of considerable variety within single deposits, that's why you see here we have Miletus 1 and Miletus 2, because if we would have just Miletus, one single ellipsis with Miletus, some samples would not fit into the ellipsis samples. Yeah, so that's why sometimes you have to play a bit with the data, but you have to also explain why. Can limit their diagnostic precision. For this reason, isotopic analysis often needs to be combined or better yet verified with other methods, most notably mineralogical petrographic analysis. This approach requires the preparation of thin sections, which are examined under a microscope in order to assess grain size, grain boundaries, fabric, and texture. These parameters are then compared with the equivalent data from ancient quarry sites. I will show you some examples soon. Other than, and mentioned in this context, and other than the statistic analysis based on numerical values then can be done even easily by archaeologists as well, who are familiar with statistic analysis and with software, statistical software. The mineralogic petrographical analysis can mostly be done only by specialists, by trained geologists. And there is just a very small group of people who actually have this kind of skills. Yeah, we have a lot of geologists, but they need to be trained exactly on this material. So that's why sometimes you mostly see this kind of diagrams when it comes to provenancing, and the other part is missing. Isotopic analysis relies heavily on reference databases of ancient quarries, a field that has been evolved significantly over the recent decades. I showed you the graph based on Norman's here. This one, it's a graph based on Norman Hertz's database, compiled by this American geologist in the late 80s. The current standard, however, is the Donato Atanasio marble database, which includes more than 1,300 data sets and was published in 2006 as part of his monograph, Isotopic Signatures of Classical Marbles. In recent years, this database has been further expanded by Walter Prochazka, primarily with material from Ephesus and other sites in Asia Minor. In addition, numerous individual studies have produced isotopic data for specific quarry sites that have yet to be fully integrated into larger data sets. This is a case, for instance, with my Miletus project, as well as many others. I've shown you these diagrams with Miletus 1 and Miletus 2. You won't find it in this way in the database of Donato Atanasio. Consequently, the probability ellipses defining the isotopic field of ancient quarry systems remain subject of variation depending on the current state of research. One advantage of isotopic analysis is that reliable data can be obtained from very small samples, which can be analyzed by many commercial laboratories at relatively low cost and compared with the published reference data sets. The graphical representation of such results has traditionally relied on proprietary software, most commonly Statistica. My isotopic analysis of most of the graphs that I will show you are based on the database of Donato Atanasio and were produced using Statistica. In parallel, I have developed a web-based tool for marble provenancing based on the same database, as on the same database of Donato Atanasio, because this is the standard. It does not include already my data, no? Because my data has not been published. This is the data that has been published and can be so double-checked, yeah? This project is still in an incipient stage and is a joint effort with the IT department of TU Darmstadt, benefiting from collaboration with a group of students. I just mentioned their names here, and here you have, so it's called Marble Signatures, and you can easily access it. We can also have a look together at the end of the presentation if you like. On the other hand, mineralogical petrographic analysis has been largely developed by Lorenzo Lazzarini. This is also the other Italian specialist on marble that has a different approach from the one established by Donato Atanasio. However, the reference database for the mineralogical petrographic characteristics of major ancient quarry sites is less complete than in the case of isotopic data, and has so far been presented only in an article for the Accademia dei Lincei that you can see on the left. As with isotopic signature, the petrographic properties of marble can also vary considerably within a single quarry district or even within a single artifact. That is mostly the reason why my data on Miletus has not been published yet, because it's extremely heterogeneous, and it's other than Histria, everything it's local, so extremely difficult to distinguish, yeah, to group, to cluster, yeah. Archaeometric research, which is primarily based on scientific method, has advanced significantly in recent decades. However, there are also many cases in which this main method reveal more limitations than reliable results. But let's return to Histria. Let us return to Histria and the stone monument of the so-called sacred zone or sacred area, where the city's Acropolis was likely located in the pre-Roman times. This sacred area has been at the center of the Romanian archaeological research in Histria for the past 70 years and has been thoroughly studied and documented thanks to the work, to the activity of, and I can mention only a few of them, Dionisie Pipidi, Petre Alexandrescu, Alexandru Avram, Monica Mărgineanu Cârstoiu, Conrad Zimmermann, and Iulian Bărzescu lately. On display at the left is a plan of sacred area with the main cult buildings from the Greek period and, I missed this, and a photograph of the foundation of the Archaic temple dedicated to Aphrodite. It's not, but you can see the Aphrodite temple here. The Aphrodite temple is a perfect example of the type of building material used in the early phase of Histria urban development. It is a very friable Turonian age limestone quarried in the Babadag area north of the city. Within the archaic architecture and votive deposit of the sacred area, white marble appears only in a few exceptions. The foundation of the so-called monument M from the late Archaic, early classical phase, and 3 anchor stocks as votives at the northern corner of the sacrificial area, which remained visible in the sanctuary during the whole 6th century BC. Monument M is a cult building of unknown function, preserved only in its rectangular foundation, which measures 10 meters in length and has a constructed width of approximately 6.5 meters. The structure that you can see, I hope you can see my mouse, so that is Monument M, and here you can see the structure, here you can see the plan, yeah, and here's some excavation photos. The structure rests directly on the bedrock and is oriented roughly north-south, in keeping with the orientation of most of the archaic monuments. So with Temple A, which was the temple of Zeus Polyeus, and a Temple A, probably temple of Apollo Ietros, but not in the same orientation with the Aphrodite temple, which is here on the left. Yeah. The walls up to 65 to 70 centimeters thick are composed predominantly of irregular marble blocks that show no visible tool traces or marks. Alexandru Avram has proposed that this material represented spolia from an earlier small-scale structure, possibly an altar, that was deliberately profaned and destroyed. In a private discussion, Iulian Bărzescu suggested that fire might have caused the observed damage to the stone. Both interpretations, however, remain speculative. The deliberate destruction of suitable ashlar blocks for reuse in a later construction is inherently contradictory and therefore implausible. Conversely, fire would have significantly weakened the marble, rendering it friable and exposing its crystalline structure. This interpretation is not supported by the current state of preservation of the marble used in the monument M, which remains particularly hard and resistant to breakage, as I observed myself during sampling. The hardness and the bright crystalline texture of the material, which can be even observed in this screenshot. Let me see if I have a better one, I think, here. Which can be observed in this screenshot, taken from a 2000, and here, for instance, now you see where this M is. You see the crystalline structure? Yeah, it is a screenshot, yeah, from a PDF of a picture taken in 2008. And you can still see the coarse crystals of this marble and their bright color. Yeah, the marble here below, it's weathered, yeah, in the current state. But here, when it was exposed by the excavation, you could still recognize the texture already. So the hardness and the crystalline texture already provide valuable clues to its provenance, suggesting a potentially dolomitic composition for especially the hardness. Yeah, as noted above, marble is mineralogically calcium carbonate, but there are also a dolomitic variety, which chemically is a magnesium carbonate. In antiquity, only one district is known to have exploited dolomitic marble, and this is Tassos. Okay, you can see it here. Okay, you see here the diagram. Yeah, these great diagrams. You can see, depending on how many of the quarry sites, yeah, you choose to plot on such a diagrams, it becomes more and more crowded. Yeah, that's why using only the isotopic signature, it's very difficult, because, for instance, yeah, this sample is also close, yeah, to Paros lignitis, yeah, but and Paros lignitis is also bright white, yeah, spotless white, and has big crystals. Nevertheless, it is not so hard, and it's not dolomitic. So that's why you depend also on this kind of thin section, and also looking at the mineralogical petrographical structure. So, okay, where was I? So, the isotopic analysis of material plotted as grand triangle in the diagram demonstrates that it originates from Tassos Vati quarries. This attribution is independently confirmed by the mineralogic petrographic analysis conducted by Lorenzo Lazzarini. So, when I was on the spot and when I started analyzing, I was thinking, oh, this is Tassos Vati. Everybody with a bit experience in analyzing marbles and having seen marble sculptures or marble architecture can recognize it by naked eye, actually. But nevertheless, you also need additionally to these diagrams, also the opinion of an expert. So this was confirmed, and is further supported by the macroscopic, so something that you can see we don't need to understand the microscope, but with the naked eye, like including the spotless white color, coarse grain size, and exceptional hardness, as mentioned earlier. Together, these features are diagnostic for the dolomitic marble sourced from the Saliara area near Cap Vati, on the northeastern coast of Tassos. Most of you are probably familiar on the island of Tassos in the northern Aegean. Most of you know probably the quarry of Aliki, and those of you who have probably spent the summer holiday there might have visited the beach called the Marble Beach, I think. I've never been there for holiday purposes, but just for archaeological visits, and I visited only Aliki. That's why I don't have any picture from the quarries of Cap Vati, including the district of Saliara. But what you can see on this map, this is the particular thing about the Tahitian marble is that it has these two varieties. In the northern part of the island, you see this the geologic structure of this island. Yeah, the marble from the northern part of the island, including the local quarries in Limenas, I think it is called, the modern city where the ancient polis of Tassos was erected. So here, so the whole region here has also marble, yeah. But the most famous district of Tassos is the one in Aliki for the south, and this is actually calcitic marble. So the chemical structure of this marble is different. The one is a magnesium carbonate, the other is a calcium carbonate. And the one in the north is particularly hard because magnesium carbonate, it's very solid. The ancient marble quarries in this region were already identified and documented starting in the 1980s by the French-Slovenian couple, most of you probably know, Toni Kojeli and Manuela Voř-Kojeli, extraordinary experts, yeah, who conducted systematic surveys of the area. Their research indicates that the main phase of quarrying in this region of Cap Vati Saliara dates from the Roman period, as evidenced by abandoned and finished quarry products such as oval-shaped sarcophagi. Yeah, this is also very a marble that you can easily recognize in museums. I should have used a picture. If you ever travel to Vienna, go to the Ephesus Museum and you see this late imperial Parthian monument. Yeah, there you can very well observe the structure or the texture of this dolomitic marble. Yeah, so this marble is used for sculpture and also reliefs, but mostly in the Roman imperial time, which, yeah, there is, so, yeah, nevertheless, extraction technique documented in the area also attest to earlier Greek time exploitation. And I could find almost some, some pictures showing blocks with different extraction marks. So probably there was an extraction also in the early period, but you cannot you cannot see many traces anymore because they were, of course, destroyed by the later exploitation. Despite this, the marble blocks within the foundation of Monument M show neither tool marks nor regular shapes, which argues against deliberate quarrying for architectural or even commercial purposes. Instead, the material is more likely to represent collected stone that reached Histria unintentionally, most plausibly as ship ballast. Such transport would be consistent with the maritime exchange between the northern Aegean and the Black Sea during the 6th to the 5th century BC, as also indicated by a limited number of Dacian amphorae at Histria. I would like to note, albeit in a speculative manner, that if we accept the interpretation of Dacian marble as ballast, we must also acknowledge that the vessel disposing of this ballast would have departed from Histria heavier than when it arrived. For those among you who specialize in commercial relations or trading route in early phases, of a Greek settlement in the Black Sea, this observation may offer further scope for interpretation. I think it's very interesting. I'm curious what you think about it. Yeah. Okay. The next example also concerned recent finds. This example of Monument M was not part of the study of Maria Alexandrescu Vianu and Pensia from the 2010, because the finds were made later. That is also the case of the next examples. The next example also concerns recent find. The only large-scale votive offerings visible in the northern part of the sacred area during the first half of the 6th century BC. These are 3 Archaic period anther stocks discovered there, of which 2 of which were found completely preserved in situ, positioned along the northern boundary of the sacrificial area. A fragment of a third stock was recovered approximately 1 meter to the east. They were discovered and published by Iulian Bărzescu, who considered them exceptional votive objects closely associated with the maritime sphere. Importantly, the anther show evidence of prior use before their dedication. Isotopic analysis indicates a Parian origin, which is confirmed by the mineralogic petrographic analysis and supported by the macroscopic features of the material, including medium-sized crystals and white color. Yeah. Same is the case. There are two different, you see, I think here the Kouros, it's exactly in the middle of Paros Korodaki. They're a bit, yeah, outside the other anchors are just a bit outside of the other, but the petrographic analysis clearly indicates the provenance from or sustains the provenance from Paros. The appearance of these ties, it's closely linked to the development of long-distance maritime trade, in which anchors played a critical role in ensuring safe navigation. So the provenance from Paros of these anchors, which are mobile goods, doesn't actually. So I doesn't actually. Mean that they were dedicated by Parians. So in order to see where here you have also a map of oh, here, where am I? Just here. Hä? Ah, here. Just a second. It's other one. Oh, mein Bestik. Ah, okay. Here is Paros, no? And here are the two districts. The most famous one, yeah, it's the one of Marathi in the middle, yeah, and you see this this ancient quarry wall just above one of the entrances in the so-called gallery or quarry of the nymphs, which is Untertagebau, I don't know, which is a gallery. So it's not quarried like for instance, the Tahitian marble. Yeah, it's not a surface extraction, but they just went in galleries to extract one specific filon. So even they are of Cycladic origin, but we can neither say who dedicated them, yeah, and but they are not objects of commercial activity, but offerings where the material is actually a secondary matter. So they are made of stone, but they were not dedicated because of the material, but because of their function. The other stone monuments that I want to bring to your attention contrast chromatically strongly with the previous examples. This is also very, very nice. There are some epigraphists now in the audience. It is a group of two pedestals of votive statues and two honorary monuments made of a dark gray stone described in the archaeological literature and the epigraphic corpora as black marble. These monuments have been studied by Florina Panait-Brzescu, who collected further exemplars from Pantica Paion, Olbia, and Fanagorea on the northern coast of the Pontic region, and demonstrated that dark grey lithic material as a support for statues and inscriptions was part of a regional phenomenon extending through the 4th and 3rd century BC. So we have a bit, late classical period in Histria. Yeah. The dark grey stone, incorrectly labeled as marble, is very compact, also very difficult to break, and takes a black metallic sheen or color when polished. So I can encourage you also to wet, to pour some water on the stone, and you will also see the polish, how this stone look in a polished state. So polish is just, they use like schmiergel or something very abrasive, yeah, to have a very polished surface. This is how, now of course they are all weathered, yeah, but in antiquity they were shining, yeah. The thin sections, I will show you a thin section of that are the thin sections. The thin section analysis, as Lorenzo Lazzarini informed me, revealed that this material is a limestone, specifically a biomicrete colored black, I cite, yeah, I quote, by carbonaceous matter and containing bioclasts of microfossils. The texture of this material is not compatible with the known ancient sources of dark gray and black stones, such as Chios, Lesbos, or the ancient imperial quarries of Göktepe, for instance. Consequently, the extensive database of Donato Atanasio. Donato Atanasio has a database not only for the white marbles, but also for the dark marbles. Yeah. And but even though he was generous to offer me this database, I cannot use it for any statistic analysis because they are not marbles. Yeah. Which includes reference, cannot be applied in this kind. The origin of this material, therefore, requires further investigation, and a regional source along the Black Sea coast cannot be excluded. This is something that I have to discuss maybe with Albert Baltres, someone who knows the geology of the region, because Lorenzo Lazzarini suggested could also be not necessarily local, but could be maybe regional. Yeah, so this is quite interesting because I expected it actually to be imported. Yeah. Also, Miletus has some black marble. Yeah. So I was so keen of having Miletus origin demonstrated. Now, yeah. Beyond the question of origin, central issues concern both the source of the inspiration for this decorative system and the significance of selecting such a visually striking material for statues, bases, and inscriptions. The use of dark stone in architectural contexts is by no means exceptional. As early as 1949, Lucy Shaw, or the Shoe, highlighted in her seminal Hesperia article numerous monuments in which dark gray stone was deliberately combined with otherwise entirely white marble structures. Prominent example includes the sanctuary of Demeter at Eleusis, I think you would say in English. No, it's not Eleusis, Eleusis, where local dark gray limestone was employed for specific architectural elements. And I have shown one example from my database. Yeah, this is the well of the fair dances. Yeah, where you see it's, of course, it's weathered. Yeah, but you can see that the material here, it's a dark limestone. Yeah, or it's a dark material. Yeah. And Delos, where the dramatic chromatic contrast between the Eleusinian dark stone and the luminosity of Parian marble appear to have determined the choice of materials from his semicircular statue base dedicated by the Athenians in front of the porous temple of Apollo. I don't have a picture of Delos, but you can search for it. A comparable strategy is evident at Delphi. Yeah, most strikingly in the Chian altar before the temple of Apollo. Its massive pedestal is carved entirely from black Chian limestone, while the crowning molding and the two lower steps are executed in white marble. So you see here, no, this is white marble, and this is dark material. Although no photographic documentation survives, or I don't have it. Yeah, I might look, but I think I have to travel to Olympia. The use of dark stone for status bases is also attested at Olympia. In all those cases, the intensive decorative effect is unmistakable. The dark material creates a powerful contrast with the white marble, highlighting specific architectural features, or in the case of statue bases, accentuating the greenish patina of bronze sculptures that were actually standing on this basis. I would like to propose an additional level of interpretation grounded in the archaeological and cultural context in which these statue bases were found. Considering the regional distribution and the intensive trade and cultural context established by the Greek colonists along the Black Sea coast with the Getic and Scythian hinterland, regions in which Toroeutics, or I don't know, Toroeutics was a major artistic medium, the use of dark gray stone may be also understood as a conscious imitation or substitution of metal. In this perspective, the material chosen not only serves a visual purpose, but also evokes the prestige, sheen, and symbolic value of metal objects familiar from local artistic traditions. The case of the black stone statue pedestals does demonstrate that, beyond questions of origin and material, certain decorative patterns, well attested in Pan-Hellenic sanctuaries, as we've seen here, Eleusis or Delphi or even Delos, reach also the Black Sea coast. My last example, which most of you are familiar with, is the Histrian temple of Theos Megas, a Doric marble architecture and dedication of a certain Pisistratos, a citizen of Tarsos. The paleographic feature of the inscription, carved of its architrave, have led Dionysius Epiphytes to propose a construction date around the middle of the 3rd century BC, a chronology that is consistent with the detailed architectural study of Monica Marginanu. The erection of this architecture occurred during the reconstruction phase of the sacred area of Histria, following its destruction by Lysimachos 3013 before Christ, during the punishment campaign of the Black Sea Police. A phase characterized by the introduction of new material and new architectural designs. Both the Theos Mega temple and one further temple of Doric order named Temple X emerged in an architectonic context that was previously dominated by Ionic models, like for instance the Aphrodite temple mentioned earlier as being built with local Turonian limestone, the earliest temple attested in the sacred area. Both the Theos Mega temple as well as the architecture pertaining to similar burden named X exhibit marble facades with the remaining structure probably erected of local lithic material. The exact position of this structure within the sacred area can so far not be determined. So yeah, one has only the architecture, the facades, yeah. The temple of Theos Megas has been already Genau. So now you see the inscription and the Tassos, the Tassos connection exactly, that has been already subject of archaeometric investigation by Pensia, Hertz, and Sharp in the context of the study of Maria Alexandrescu Vianum on the sculpture of Histria. They were the first to show that the temple was built of Proconnesian material. Since the commissioner of the monument was a Thasian citizen, and this North Aegean island not only had extensive marble deposits, but also repeatedly supplied the building material of the sanctuary of the great gods of Samothrace, and Theos Megas is considered to be one of the Samothracian gods, so that of the deity the temple was dedicated to, yeah. Archaeological research has since been skeptical about the Proconnesian origin of the temple facade at Histria. So I must say myself, yeah, I was like, okay, because Tassos, it's a Thasian citizen, yeah, it's Theos Megas, and there is a connection with this Samothrace where most of the material actually Tassos Aliki, yeah, so the calcitic marble. Indeed, a macroscopic expertise of the material evidence gray irregular spots. I don't know if you see them here in the material. There are some stripes, but they are quite irregular. Common of the Thasian calcitic marble from the Aliki quarries and not of the Proconnesian marbles. Nevertheless, it has to be emphasized that chromatics and patterns vary extremely within one and the same deposit and are therefore seldom diagnostic. The isotopic signatures, of the 3 marble samples I took from the pediment, one Sima block, and the Geisen plot all in a zone of the overlapping field characterizing the deposit of Proconnesos and Tassos Aliki. So you see another graph here, yeah, and you see actually 6, not 3. Yeah, I told you I took that 3 samples, yeah, but on this graph I also plotted the samples that the previous project of Maria Alexandrescu Vianu has taken and analyzed. And you have to know this is something very important. Archaeometric data remains valuable. Yeah, the only thing that changes is our knowledge of the reference data. But having old material, you can still reinterpret it. Yeah, you can always use it again. And the interesting thing, if you look, the sample, the distribution pattern, I was very surprised. The distribution pattern of the samples I took and of the 3 samples Alexandrescu Vianu took from the architrave and a column shaft have a similar distribution. So two of them are exactly here in the, in the Tassos Aliki field, while the remaining one is actually quite far away, within the field of Proconnesos 1. Yeah. Nevertheless, okay, where are I? The provenance is offered by the mineralogic petrographic analysis, which show the very typical mortar. So this is a sample. This is a sample from the Histrian material, yeah, and you see the texture of it, which is comparable with a sample from the quarry. Yeah, this is a sample that I have an extensive database with not only isotopic, but also thin sections. Yeah, so, and you can see that the texture, it's not compatible, yeah, with the texture Tassos Aliki marble has, but with the one we know from Proconnesos. Yeah. So I can state with a high degree of certainty that the marble of the Doric architecture commissioned by a Tatian in Histria is of Proconnesian origin. Same is the case of the other Doric, I will show it at the end, Doric architecture of the called Temple X. This is a case of imported, yeah, or itinerant architecture. The structure erected in the sacred area of Histria during the Hellenistic period was carved from the marble from the island of Proconnesos, which is indeed mentioned in several ancient texts as a source of marble for construction, and was previously discussed case of the, for instance, for the Artemision of Ephesus, which is also in the, it's an archaic example. Nevertheless, the exact circumstances of the marble exploitation on Proconnesos prior to the Roman period remain unknown. Yeah, if any of you has any hint on that, I would be very grateful. The island belonged most probably to the Hora of Cyzicus and started its large-scale exploitation in the Hellenistic period, when it became the main supplier of construction material for the Attalid program in Pergamon and their donations, among them, so the Attalids donated votives in form of architectural buildings, among them the Eumenes Stoa, one example of itinerant architecture built by Pergamenian craftsmen with Proconnesos marble and erected on the Athenian Acropolis. This is a very famous study of Manolis Kores, on the architecture. The political alliance between the Attalids and Cyzicus by the marriage of Apollinis by Attalos I could have facilitated the access of Pergamenian constructors and architects to the marble supplies of the island and created the premises for the distribution of marble architecture. So it's a distribution of marble architecture, not of marble, of Pergamon design, in the Mediterranean. So I will show you one last graph with the whole on the material from with some other, smaller artifacts. For instance, for this day to this, we can discuss about it. I'm still waiting for the mineralogic petrographic analysis. But you can see it's not clear. Most of it, it's here in the overlapping region of Tassos Aliki and Proconnesos, and most of the material, if we just break it down to like a very gross statistic, it's actually either Thasian, or Proconnesian. To sum up, the archaic construction phase of the Histrian Acropolis relied primarily on local materials, with marble used only exceptionally and unintentional in building contexts. Marble material appears in cult contexts, but sporadically and exclusively as finished votive objects, such as the anchor stocks or the small kuros. There is no evidence of economic activity involving marble as raw material for architecture in the Archaic period. For example, the marble blocks used in the foundation of the monument M most likely reached the Black Sea coast not as a trade good, but as a ship ballast from Tassos. Similarly, marble anchors and the kuros were valued for their function as votives rather than for the material itself, which, while renowned, Parian marble was renowned in this time for its translucent properties, was secondary to the purpose of offering. The dark gray marble bases that date to late classical Hellenistic period show further that the Black Sea colonies adopted pan-Hellenic trends, such as the use of bichrome elements or dark bases in sacred architecture or public architecture. The Hellenistic period marks a turning point in Histria's construction tradition, introducing new designs and allogenic materials, as well as new architectural forms. Marble facades, so it's not the material, it's the facade as such, as seen in the Theos Megas and Temple X, were bulky transport goods, demonstrating the deliberate import of architectural material for construction purposes, most likely also accompanied by specialists in carving this stone. Thank you for your attention.